We've all heard that term, right? The Dark Ages. It paints this bleak picture of an era where human progress just completely ground to a halt. But the reality? The lights of science actually never went out. They were just shining brilliantly somewhere else. In this explainer, we're going to look closely at how a truly borderless human endeavor built the absolute foundation of modern science. We're diving into medieval knowledge networks and exploring what was, quite literally, a global synthesis of reason. Here is our map for the journey today. We'll be covering 4 main parts: gathering the baton, which is preservation; running the leg, meaning innovation; building the track through institutionalization; and finally, the handoff, or transmission. Let's jump right in. Just to ground us for a second, look at the sheer scale we're dealing with here. We are tracking a massive, centuries-long evolution. It starts with the establishment of the Abbasid Caliphate in the 8th century, moves into incredible breakthroughs in math and optics in the 9th, sparks the very first European universities in the 11th, and ultimately builds into a deeply interconnected global transmission network by the 14th century. All right, part 1, gathering the baton, preservation. So we're kicking things off in the Abbasid Caliphate. This was an incredibly expansive empire stretching all the way from the Iberian Peninsula across North Africa and deep into Central Asia. And right there, a massive intellectual transformation was unfolding. It was driven by this really powerful concept called ilm. Now, this wasn't just some casual hobby for a few rich guys. Ilm was a deeply ingrained Islamic cultural and religious mandate. It basically stated that the pursuit of knowledge was a fundamental virtue. And because this cultural mandate was so strong, it drove major state patronage, famously giving us things like the House of Wisdom in Baghdad. And with that massive state backing, they pulled off these unbelievable translation projects, bringing Greek, Persian, and Indian works directly into Arabic. But here's the crucial part. They weren't just passively copying old, dusty scrolls. No, they were actively critically examining, correcting, and expanding on those ancient texts. They also started institutionalizing all this knowledge, creating bimarstans, which were these early teaching hospitals that actually combined clinical practice with teaching. It essentially created this super connected community of scholars stretching from Cordoba all the way to Samarkand, all working toward the exact same goal. Moving on to part 2, running the leg, innovation. Because it wasn't just about saving the past, right? It was about inventing the future. Take math, for example. Algebra actually derives directly from a foundational text by the early 9th century mathematician Al-Khwarizmi called Al-Jabr. He came up with these systematic procedures for solving equations. By treating unknown quantities symbolically rather than just, geometrically, he completely revolutionized the field. And get this is wild. His Latinized name was algorithmi. That is the direct root of the word algorithm. So Al-Khwarizmi literally laid the groundwork for the algorithms powering whatever device you are watching this explainer on right now. And these leaps forward weren't just in math. They extended right into early experimental physics. You've got Ibn al-Haytham proving that light travels in straight lines, enters a pinhole, and projects an image. He used this exact experimental setup in a dark room, which was essentially a camera obscura, to definitively refute the old Greek idea that vision happened because rays shot out of our eyes. He proved that light enters the eye, and in doing so, basically documented the mechanics for the very first camera. Now, over in astronomy, we have Nasir al-Din al-Tusi. He developed what's known as the Tusi couple. It's this brilliant mathematical device designed to convert circular motion into linear motion. And you might be thinking, okay, so what? Well, this specific innovation led to highly accurate navigational tables. And more importantly, it provided the exact conceptual tools that Copernicus would end up using centuries later to totally reshape our understanding of the cosmos. All right, part 3. Building the track, institutionalization. Let's jump over to 11th century Europe. At this point, all this evolving knowledge really needed a structured, permanent home. It had to move out of the informal monastic networks and into professionalized academic settings. Enter the very first universities in cities like Bologna, Paris, and Oxford. They offered students a deeply structured curriculum known as the liberal arts tree. You'd start with the trivium, that's grammar, rhetoric, and logic, before leveling up to the quadrivium, which was arithmetic, geometry, music, and astronomy. They were literally building the durable social architecture for learning. And inside these new university walls, a very specific vibe took over, a method called disputatio. This was the scholastic approach of rigorous, highly structured debate, which insisted on a strict logical progression from your premises all the way to your conclusions. Heavy hitters like Peter Abelard and Thomas Aquinas used this exact method to systematically question authority and reconcile Christian theology with Aristotelian philosophy. It trained specialists and ensured that scientific advances could actually be built upon generation after generation. Which brings us to part 4, the handoff, transmission. This final leg of the relay reveals these incredibly vibrant cross-cultural networks that were practically stitching the world together. Just think about the mathematical tools for a second. On one side, you have Roman numerals. They are clunky, they completely lack a zero, and honestly, they are an absolute nightmare if you're trying to do long division. On the other side, you have the Hindu-Arabic system. It includes the digits 0 through 9 and enables wildly advanced computation. Imagine trying to do higher-level physics with Roman numerals. Adopting the Hindu-Arabic system, which started in India, got systematized in Baghdad, and then flowed into Europe through translation hubs in Spain and Sicily, quite literally transformed the math of the Western world. And at these critical geographic hotspots, the flow of information was staggering. Along with those numerals, Ibn Sina's The Canon of Medicine was translated and quickly became the absolute gold standard in European medical schools for centuries. You also had brilliant scholars like the Jewish philosopher Moses Maimonides, acting as crucial intermediaries, interpreting Greek philosophy through an Islamic context for European thinkers. This massive, borderless flow of texts built the durable scaffolding that would eventually hold up the entire scientific revolution. So I want you to really think about this for a second. Isn't modern science actually just a massive cross-cultural group project that spans centuries? The Dark Ages were anything but dark. They were a vibrant, highly collaborative global continuum. Let that sink in. We all share a cognitive landscape that entirely transcends borders, which proves that human collaboration across languages, cultures, and time itself is the true engine of progress. Thanks for joining me for this explainer, and I hope it sparks your curiosity to look a little closer at the incredibly rich, connected history of how we know what we know.